today we are working on 3:4 ratio and proportion. We are splitting up 3:4 into two different sections. So today we'll do part 1, tomorrow will be part 2. Alright, so here's our first example. In addition to what's already on the screen, the table here that you can see as I kind of highlight it gives the prices for different sizes of different sizes of apple juice. And then also I'm going to add in this price here. I'm trying to figure out what the unit rate will be for this one in the table. So price would be $1.56 for 48 ounces. So this is how you could use this maybe in the real world of trying to figure out what the best price is. So to find the unit price here, and they said to find it for the cost per ounce. So the cost per ounce. So I know my cost is going to go first. I'm going to divide it by how much I have here. And that's how I'm going to find this unit rate. And unit rate means how much one would cost. So how much is like 1 ounce? So I can here take my price of 0.72 divided by 16. And that is going to give me 0.045. $1.20 divided by 32. And that would give you 0.0375. Keep going, $1.60 divided by 64. That would give me 0.025. And $1.56 divided by 48, which you can see that they're going to put it through here, is going to equal 0.0325 per ounce. So this is the price to find the unit rate is 0.0325 per ounce. Now my question, since you have all this information, what is the best price for this apple juice? So if you were looking to go to the store on the shelf, tons of different apple juices, figuring out what is the best price. I got a 16, a 32, a 64, and a 48 ounce. What is the best price? Well, this one I'm paying almost a little over 4 cents per ounce. Here I'm paying, and I guess I probably should be a little more detailed because these are all awful close. Here I'm paying 4.5 cents per pound. This is 0.03, so 3 cents, almost 4 cents, so this one's more expensive. Here it's costing me a little over 2 cents, and this one is a little over 3 cents. So obviously this is my cheapest ounce per ounce that I'm paying. So I am buying more ounces, so 64 may cost me more money. Okay, it is the most expensive, but I get more juice in this container than any of the others. So when you find the unit rate, you can see here that 0.025 is my cheapest, so therefore that would be the apple juice I'd want to buy. Alright, go ahead and pause the video and read the problem. So you can see here that we were trying to find how long it would take Lance to ride 295 km. So here we can find what it costs, what his average race speed was. Here and here is my important information. I'm pulling out that important information, and I can establish that this is given. So it took him, the total distance would be here on top. Distance. And how much time is going to be here on the bottom. And this is representing the time we're trying to figure out, because we're trying to figure out how long would it only take him to ride 295. So we can, as you can see here, cross multiply 3630 times t gives you this. And then on the other side, the equal sign is 92.5 times 295. So cross multiply and then divide, because obviously I'm trying to get t by itself. So I'm going to divide by 3630, whatever you do one side, you need to do the other, and you can see that done here. And then that's going to give you t equals about 7.5. So what is that saying? It would take Lance approximately 7.5 hours to cycle 295 kms. So the hardest part here is being able to pull that important information out and then being able to set up. Remember, whatever units you were putting in on top, you need to put in the same units across when you start to cross multiply and divide. So distance over time, because I'm trying to figure out how long it would take him to ride this much. So how much time? Well, it would be a total 7.5 hours. So in 295 kms per, because one thing that I haven't really established, a divide sign or miles per hour, you may see this slash or over a line like this, miles per hour, is telling you the word per. So that's kind of good information as well. So it takes 7.5 hours to travel 295 kms. All right, so this is probably the hardest problem yet. This gray kangaroo can run 40 miles per hour. So I want to know how fast this kangaroo can run per second. All right, now this is going to be tough. You guys have seen this in science before by creating your railroads. So the first thing I'm going to do here is I'm going to show you what they have, and I'm going to try to explain this. This is what's given. Right now the kangaroo can run 40 miles per hour. So I know per hour, I got 40 miles per 1 hour. And I need to, and this is where I set up a railroad. This is what I call a railroad. It really doesn't. Squint your eye, tilt your head, you'll see the railroad. 40 miles per hour. And I'm trying to create or find what the kangaroo speed would be in feet per second. So at the end of my railroad here, I know I want feet per second. So I put in what I start with every single time first, and then at the end I look to write what I'm trying to get to. So my denominator needs to be in seconds, and my numerator needs to go from miles to feet. So we need to start creating cancellations. So they are converting their miles first, as you can see here. So we're going to go miles to miles. And then after you go from a mile to mile, I want to create feet. That's what I'm trying to go for. Feet is what I'm trying to end with. And then I need to go, I'm at my feet, so that's good. This is going to cancel. Feet, and we need to get to seconds. So right now I'm at hours, so to cancel this way, I need to go hours, because it's got to be the same, and then I can convert to seconds. Actually, be easier to convert to minutes. Okay, so hours would cancel, leave me with a minute. It says minute, just not very easy to read. So minute's going to be up here. Minute to seconds, and then I can leave seconds down on the bottom, because that's what I want left. Seconds matches seconds. So now I just need to go through and punch in what information I know. Well, in 1 mile, there's 5,280 feet. In 1 hour, there's 60 minutes, and in 1 minute, there's 60 seconds. Plug in the numbers we know. Well, we traveled 40 miles per 1 hour. So anytime you have this line here, and this is the important piece, you need to divide. And anytime you hit the crossing of your railroad, you need to multiply. So there's a multiplication there and here. Okay? Dividing all the way through. 40 times 5,280 times 1 times 1. Okay? And then on the bottom, I would take 1 times 1 times 60 times 60. So when you multiplied 40 times 5,280 times 1 times 1, you get 211,200 feet. And then do all of your denominator. 1 times 1 times 60 times 60 gives you 3,600. We said that this line here would represent a division, which is not a very straight line, but that's a division. So take this divided by this, and you're going to get 58.6 repeating. They did the same exact thing. So the first thing that they started doing, here's their road. I put these lines in, which means multiplication. We're converting 40 miles in 1 hour to how many feet per minute. So what's left with here, you can see miles cancel, and then we want feet, so that should be my ending. I can get hours to cancel and minutes to cancel. So I get left with feet per second left. So we know my units match up, and there's in 1 mile there's 5,280 feet, in 1 hour there's 60 minutes, in 1 minute there's 60 seconds. This is a conversion that you're going to need to know quite a bit, that we actually do a lot in this section with. So add them, or multiply them across, and then divide when you finish, and you get 58.6. So the kangaroo speed is about 58.7 feet per second. That's all for today.